Hey, Garrett.
Hey, Miss Sparks.
How are you?
I'm good.
Good. Do you have specific questions, or you just want me to start working on some of the homework with you?
I just want to go through the homework.
Okay. I'm just double checking to make sure I have the right numbers that we're supposed to do. What are we, 3 through 45 odd? Is that right?
Yeah.
Okay. Wow, my computer's so loud. Yes, love?
The only way I can get there is I-75 from like Michelle's to the school.
Hold on, just hold on, Garrett. I'm sorry.
The available day for volunteer is Thursdays. And it's 1 to 3, or like 2 to 4 or something.
Does that make you? Sorry, Garrett. Hold on just a second. Mackenzie has to ask me a question about her senior project. I'm really sorry.
It's fine.
Okay, I'm back. So sorry about that. Are you there?
Yeah.
Okay, good. I've been clicking so many buttons today that I get this paranoid feeling that I'm disconnecting somebody sometimes. And I'm like, oh. Okay. Number 3. Okay, x squared equals negative 28.
And then it'd be x equals square root of negative 28.
Yes. So, yeah, you're going to take the square root of both sides. So that gives you x equals. And then technically, this breaks down to negative 1 times 7 times 4, because you want to separate that negative 1 out of there, because that's going to be the I part. And then you've got the square root, because you've got to factor what's underneath there to pull out any perfect squares that you have. So you have the square root of 4, which is 2i. And then the 7 is not perfect. So it has to stay in underneath the radical. So the answers are plus or minus 2. I square root of 7.
I don't actually get that.
Okay. Let me break that down a little bit better. Okay, is it the factoring part mostly, or is it everything?
It's the third or the second step for you.
The second step, where I'm factoring everything inside the radical. Is that correct?
Yes.
Okay. All right. Bear with me just one second. All kinds of technical issues today. I'm really sorry. Okay. So what I want to do, And that's just the fun of Algebra 2 is there's factoring, factoring, factoring. So basically what we kind of talked about yesterday in class was the fact that the square root of -1 equals I, correct?
Mm-hmm.
And then what we want to do, so basically what you're doing is you're breaking this down into 28 times -1 because you want to separate that -1 out because that's going to be the part that you're going to say is the I. So you want to break that away first. And then the next part, and this is kind of how I try to explain it, you can do one of two things. You can factor this all the way down and do like 14 and 2 and 7 and 2 and get it like that. And then look for all of, like, you know that in order to be a square root, you'd have to find a pair, right? Because a pair makes a perfect square. So that's 4. So that's 7 and 4 underneath. So all I've done is factor what's underneath the radicand to be -1 because I want to pull that because that's going to be the I part. And then 7 and 4 because I know 4 is a perfect square. And I'm looking for every perfect square that I possibly can. I could have written it like this. -1 times 7 times 2 times 2. And anything that repeats can come out. And then this can come out as the I. And anything else that does not come out of underneath the radicand because it's not a perfect square has to stay in. And it's plus and minus because because if I say the negative square root of 7 times the negative square root of 7 is going to be a positive, right?
Yeah.
So
Your audio just cut out.
I'm sorry. Does that help?
Your audio cut off for a second.
Oh, it did? Okay, I'm sorry. Does that help a little bit walking through it that way? I think the more we do it, the more you'll become comfortable with it. It's just one of those things where I think, practice makes perfect kind of thing. So let's keep doing a few and see if we talk it out together and see if that helps a little.
Okay.
Okay, so now the next one, number 5, is z squared plus 8 equals 4. So what you want to do is get your variable on one side and your constant on the other. So we're going to subtract 8 from both sides. And that's going to actually give us a -4 on this side. Right?
Right.
Okay. So now I'm going to take the square root of both sides. So I'm going to have z equals, and then underneath this, how I want to think about this, once again, I want to separate that negative from that 4 because that negative square root of 1 is going to be my I. Okay.
Mm-hmm.
And now what's the square root of 4?
2.
I'm sorry?
2.
Yes. So it's going to be plus or minus 2i.
Okay.
Does that make sense?
Yeah.
Is it starting to be a little bit clearer?
Yeah.
One more. More we do, I think the better that'll be. Okay. So now, hopefully this won't be too jumbled for you, Garrett. Sorry. I have 2x squared plus 31 equals 9. So I'm going to subtract 31 from both sides first, because whenever you're doing equations, you're always kind of working PEMDAS in reverse on these when you're isolating a variable. So you want to do your addition and subtraction first. So that's why I'm doing that first, which that cancels. And this is going to be, let's see, negative 31 minus 9, or negative 31 plus 9 rather, is going to be, it's going to leave me 22, right? Negative 22. Does that sound right?
Yeah.
Okay. Don't be too trusting, Garrett. I can make those simple math mistakes. So you no, Miss Sparks, that's not right at all. Okay, divide both sides by 2. That's next. That's the multiplication and division. So that gives me negative 11. And then I'm going to take the square root of both sides. And remember, this negative 11 here is the same as negative 11. Oops, my bad. It's the same as negative 1 times 11. Because I want that negative 1 because that's going to be where my I comes in. So it's going to be plus or minus I times the square root 11.
Okay.
Okay. Did I just quit sharing with you?
Yeah.
Ugh. Yuck.
Miss Sparks.
I think she's on mute.
Yeah. Miss Sparks, you're on mute.
I don't know how that happened, guys.
Oh, okay.
I thought you were ignoring me, Brooke, because I was talking to you.
You were?
Yes.
No, I couldn't hear you. I was so confused.
Even Mackenzie laughed. I go, okay, she's not talking to me.
No, I just couldn't hear you. I was really confused.
Well, it's funny because I almost said, thank you, Garrett, for talking to me since Brooke won't talk to me. I was really going to give you a hard time.
No, I was really confused.
My balloon-headed self was on mute the whole time. There you go.
Well, I was like, can
I have no idea. Momo just asked me, how long have I been on mute, guys?
Like 30 seconds. You just worked
Oh.
that whole problem, and I couldn't hear you.
Oh, okay. So I just worked an entire problem. Well, do you want me to rework it, or did y'all pretty much follow along?
No, I don't know like how to do it. Like starting at problem 29.
Oh, okay.
I'm good up until like there-ish. So
Okay.
but-
Well, okay. So have you already checked them in the back of the book?
yeah.
Okay. So you know you're good for you. So you know you're good. You're right thus far.
Yeah.
Okay. What did you say, Garrett?
I'm completely in the dark.
Oh, okay. Well, it's. I mean, we'll work through it.
I'm at 11 though. I worked.
Okay, so you've already done 9.
Yeah.
See, Garrett, you don't even need me. You just think you're in the dark.
Well, I know that I will probably eventually when I get to the later problems.
All right. So, oh, help me, Jesus. Brooke, you probably should be running math lab. I put myself on mute.
I think it was when you like you weren't sharing your screen with us.
Oh,
You went to share it again and it just like didn't work.
And you were like, please help Miss Sparks.
Well, because mine like wouldn't work on my phone, so I'm doing it on my like computer now. So I was like, oh, now it like this one's not working. But then like I was like, then you like had it on mute. So
all right. So Garrett, did you get plus or minus I for number 9?
Yes.
See, you don't need me, Garrett.
Well, I immediately got hung up on 11, so.
Bless your heart. So you do need me, or are you just trying to make me feel better about myself since I put myself on mute and I can't write? And I was talking to Brooke and she wasn't talking back because I'm on mute. Lord, help Miss Sparks today. Okay, so let's take a look at number 11. And then, Brookie, you're at 29, you say, right?
Yes, 29.
That's where you're hung up? Okay.
Yeah.
All right. Okay, now for me personally, this is what I would do here, Garrett. Once again, kind of looking at PEMDAS in reverse. And this is always really, really important to make life simpler. You want to kind of do this in reverse order. So I really want you to think about this at the top, the parentheses. That's going to be the very last thing that I'm going to deal with. Okay? And I don't really have any addition and subtraction outside of a parenthesis. So I'm going to do multiplication and division. And technically this -5 is being multiplied to this piece right here. So what I'm going to do is divide both sides by -5. The very first thing that I'm going to do. And so that cancels this out, and it actually leaves me n minus 3 squared equals -2. And now I'm going to take the square root of both of those. Okay? And that gives me n minus 3 on this side. And it leaves me with a plus or minus square root of 2 on this side. Which technically, I've already told you that when you have a negative, what you want to do is immediately factor that so that the negative comes out, because that's the imaginary part. So we got plus or minus I times the square root of 2. But now we still don't have n by itself yet. So what I'm going to want to do is add 3 to both sides, and it leaves me with n equals 3 plus or minus I times the square root of 2.
Yeah, I would have never figured that one out.
Oh, well, good. Thank you for making me feel needed. Yeah, that one was tougher than some of the rest of them, just because of that a lot of times students are going to look at this and think, okay, well, somehow I need to subtract that -3. And you really cannot deal with that until you've dealt with the -5 on the outside. So I always say, a lot of times, just as a good reminder before a quiz or a test, it's good to write PEMDAS and draw yourself that arrow that goes up, knowing that you're going to be working that in reverse to unpack. Because when you work with order of operations going forward, that's when you do the parentheses, exponents, multiplication, division, addition, subtraction. But when you work with equations, you have to think of it as you're unpacking those order of operations. And the more complicated our equations get as we progress forward through Algebra 2, that's going to become more and more essential to make sure that you're unpacking it in the correct order. So, but does it make sense to you now that we've talked through it, Garrett?
Not entirely.
Not entirely. Okay. Where could I help you, do you think?
Well, it's just you did a lot of, like, the way you solved it was not really how I thought it was supposed to be solved.
Okay. So at this first step up here, do you feel good about that? Do you feel like you understand that now, and you feel like you would work it that way going forward?
Yeah.
Okay. So then the next part, I did that square root thingamabob to both sides. I actually ended with n-3 squared equals a square root of -2, or the equals -2. And then I took the square root, which takes this piece off of, takes the radicand off this, and it left me with this.
Didn't know why you were doing that. No, it's because it had the square on it. That's why you did that.
Oh, okay. All right. Good. Sometimes it just it gets, it helps to kind of work your way back through. And then this is something that we were doing on all of the previous problems, breaking that down to get that -1 off of there so you can get the I. And then the very last thing that you do is here, where you're going to add that 3 to both sides, because you kind of want to get this whole side over here resolved first. Like, what am I gonna end up adding 3 to? And it's unfortunate. I think that's, hey, Brookie,
Yeah.
is that the only one like that? The rest of them, we're just going to go straight into adding and subtracting, aren't we?
Mm-hmm.
Oh, that's kind of unfortunate.
Yeah.
Those probably we need more practice on.
Yeah, that was one, like, I'm in math study hall with Miss Murphy, and she, like, had me work it, like, 3 different times because, like, she got confused.
Okay.
But that was the only one, so it's, like, it's hard to practice.
Yeah, it really is hard to practice that one because it's the only one like that.
Yeah, so.
Yeah. Ugh, hate that.
Mm-hmm.
Oh, well. I'm glad Miss Murphy was working through it with you.
Yeah, that's how I'm so far, like, through it.
Oh, okay. All right.
Well, number 13 in combined like terms.
Yes. Number 13, you're just combining like terms.
Is it 17 minus I?
Or
did I mess that up?
For 13. I'm sorry. I was looking at the wrong one. That is it. No, you're not messing it up.
Okay,
you did great. You did perfect. And
For
that's
13,
the way.
do we put plus minus 17? Or is it just 17?
It's 17 minus I.
Okay. I forget when you're supposed to put the plus and minus.
When you're supposed to put the plus and minus is
Yeah.
when you're solving the
Okay.
quadratic equation. And I'm going to write something about that in just a second so that I can clarify that with you guys. When you have, let me see. Let me get this erased and then I can start. On numbers 3 through 11, you're solving for quadratic equations. So you've got that x equals something. And so when you have x equals something, you're actually looking for all the possibilities that something could possibly be. So when it's an equation where there's an equal sign and you're solving for x, that's when you'll have a plus or minus. When it's an expression, which that means there's no equal sign, you're just simplifying or getting an answer to, there's no equal. Like you'll notice on numbers 12 through 20, obviously you were only supposed to do the odd on that. So 13, 15, 17, and 19.
Right.
There's really no equal sign on those.
Right.
So that way you don't have to have the plus or minus.
Okay.
But when you're solving for X or Y or R or P or whatever the variable is, you're looking for all the possibilities that X could be in that situation.
Okay.
So like if it's plus or minus, like let's just take something really, really simple. Let's say it's X squared equals 25. So I'm going to take the square root of both sides. So X equals plus or minus 5.
Okay.
Because you could, all the possibilities for X, negative 5 squared equals 25, but positive 5 squared equals 25.
Okay. Right.
So does that kind of help clarify when?
Yeah, for sure.
Oh my goodness. My dog is about to knock the computer off because it's trying to walk right through the cord.
Cool.
And this is the dog that tries to talk to me while I'm on math lab because she thinks I'm talking to her. Oh, Lord, help me. Garrett, did that kind of help explain when to use for you? Did that help clarify when?
Yeah.
Mute again? What did I do?
I think it just cut out.
Yeah.
Oh, okay. All right. I was like, yeah, y'all are going to have to be like, Miss Sparks. Okay. Garrett, do you want me to walk through 13, 15, 17, 19, or just make sure you have the right answers?
Well, I'd like to get them all in order because I don't want to have to go back and mess up the spacing on my paper. It's 15, 6 minus 4i.
And then 15, how'd you do on it? You want me to walk you through it?
I said it's 15, 6 minus 4i.
That number 15 is not that, but it could be a distribution problem.
Okay.
So let's talk about that one for just a minute. So we have -1 plus I minus 7 minus 5i. So what you have to do on the subtraction is this subtraction symbol right here. As a matter of fact, I'm going to underline it in a different color. You have to treat that like you were actually multiplying everything here by -1. So I'm actually going to rewrite this. Lord, please help Mrs. Sparks today. -1 plus I. So this would be like -1 times 7 gives me a -7. And then -1 times a -5i is going to give me a plus 5i.
Okay.
So that is going to, that changes that. So that's probably where you got your 4i. And this is actually going to be plus 6i. And now I've got this -1 and -7. So that's going to be a -8. And I do want to make sure that you guys know your answers really should be in standard format.
Right.
In standard format is when the real number is first, followed by an operation of some sort, plus or minus, okay? And then the imaginary number goes last. Okay? So that's standard format. So you always want to make sure that that real number is first. Okay, Garrett, have you tried number 17 yet? Don't forget, because of the subtraction sign, That's like multiplying everything in that second set of parentheses by a -1.
Let me check it real quick.
Okay. Did you say you wanted me do you want me to do it and then you check it, or you just want to tell me your answer, or you're going to do it?
Sorry, I was checking my phone because someone was calling on my landline.
Oh, okay.
Okay, I fixed it up. I'm gonna try to work this one on my own and see if I get the right answer.
Okay.
Okay, is it 19 minus 9i?
It is. I'm not even going to bother to walk through it. Good job. All right, how about 19?
Write it down.
I think I need to try and find some additional problems like number 11, though.
Yeah.
Because I feel like there's a few of those. There might be a few of those on the actual test. That's going to require more work. I mean, more practice.
1921 plus 9i.
Yes. Perfect. Doing great.
21's a multiple choice.
Multiple guess. Well, you could definitely rule out A. Because you're on that one, if you're just actually combining.
Is it D?
No, because don't forget you have to multiply that second 4i by that -1. So you're going to have 3i minus 4i. So it's actually C.
Okay.
Does that make sense, or do you want to see it?
I get it.
Okay. All right. So then 23, we're multiplying. And the key part of multiplying is knowing that when you multiply I squared times I squared, then that actually changes to a -1. So number 23, we're just distributing I to 4 minus 8i. So you've got 4i minus 8i squared, which is the equivalent of 4i minus 8 times -1.
Miss Sparks?
Yes.
On 23, the problem is like -I.
Ooh!
So I think...
Thank you.
Yeah.
Thank you for catching that. So -4i, and then so it's going to be -I times a -8i, so that's going to be plus.
Yeah.
So that's going to be -8, right? Did I write everything right thus far? Thank you so much.
Yeah. Do you just carry the negative to the... Yeah.
And so all I'll need to do now is I need to change it into standard form. So my final answer has to have the real number first and then the imaginary second. And the key thing when you're rewriting something into standard form is to remember that in algebra, every sign has a number and every number has a sign. So you got to make sure that when you rearrange a number in an equation, that sign actually follows the number. Did that make sense, Garrett?
Yeah.
Okay, good. All right, so Moving right along to number 25. And I looked ahead to number 29. That's when we get into the conjugates and stuff like that, right, Brookie?
Yes.
Fun stuff.
Oh, yeah. Super confusing.
Well, and also the other thing I want to say is the book writes their answers differently. And I'm not sure how Miss Wynn writes them, but I'll write it both ways for you guys.
All right.
But the book does write their answers slightly different than I do. So, but maybe Miss Wynn writes it that way. I'm not really sure. So she probably does write it the same way the book does.
Mm-hmm.
I'm just lazy. And it's really lazier the way I do it. So. Okay, on these, you're going to FOIL. So I'm just going to write that over to the side, FOIL. So we got our first, which is -2 times -1, which is going to give me a +2. And then outside is -2 times 4i is going to be -8i. And then inside is 5i times a -1. So that's going to be -5i. And then last is -2, or is it's going to be 5i times 4i, which is going to be a +20i squared. So I'm going to combine like terms where I can. So that's going to be -8i and a -5i. That's -13i. And this is technically 20 times -1. So that then looks like this. And now I'm going to combine like terms. So 2 minus 20 is -18 minus 13i. Did that make sense, Garrett?
Yeah.
Okay, cool. And then 27 is my favorite thing, and I always try to bring this out as much as I possibly can because this comes up in trig identities and all kinds of places, is this one is the difference of two squares, or in this particular case, you could say it's like a binomial multiplied by its conjugate, which is the whole principle that we're trying to do when we multiply, when we're trying to get rid of, we're trying to rationalize the denominator of a complex rational expression. That's what you're doing, is you're multiplying by its conjugate. And remember when we had in our factoring and foiling earlier on, I think it was 1.5 and 1.6, or yeah, no, 1.4, 1.3 and 1.4 was all of our factoring units for this particular chapter on quadratic functions and expressions. You can see that everything about this looks exactly alike except for the operation in between the two numbers.
Right.
And so what that means is this, then the answer, if I were to FOIL this, just like I did in number 25, these middle two things would cancel each other out. So the oi would go away and you'd only have the F and the L, which is 64. 8 times 8 is 64.
Mm-hmm.
And then -3i times +3i is -9i squared, which then looks like 64 minus 9 times -1, which then becomes this, which then becomes this. So your answer is 73. But just so that if you all need me to, I can actually prove this to you. But that is why when we get ready to do this, you want to multiply by the conjugate, because what you're trying to do is get rid of that middle term,
Right.
so that you get a real number.
Mm-hmm.
Because the reason why you can't have I in the denominator is just like you can't have a radical in the denominator. I really is the square root of -1.
Mm-hmm.
So that couldn't be in the denominator because it really is a radical. So
Right.
that's why when we get ready to rationalize denominators in the next one, that's why you're actually doing it.
Okay.
Okay?
Mm-hmm.
All right, so do I have enough room to do? I'm going to leave number 29. 29 is 6i divided by 3 minus I. And once again, the whole point of doing this is because we can't have an I in the denominator. So we're going to multiply it by 1, but it's actually a form of 1 where the top and the bottom are going to be the conjugates of 3 minus I. And the conjugate is literally the same exact thing with a different operation in the middle.
Mm-hmm.
But in order to not change the value of the fraction, oh, Lord. She tries to talk to me because she thinks I'm talking to her. Come on, go out here. I'm not talking to you, buddy. That's just the weirdest dog ever. And now she's looking at me like, I was talking to you and you put me outside. Sorry about that. Okay, so on the top, we got to distribute the 6i to the 3 plus I. So that's going to be 18i plus 6i squared. Because what I've done is distribute this to both of those.
Mm-hmm.
And then on the bottom, this is quote unquote the difference of two squares,
Mm-hmm.
or multiplying by the conjugate. So I've got a 9 because 3 times 3, then that middle term, they would cancel out.
Right.
Minus I squared.
Okay.
Which all of that rewritten is 18i plus 6 times -1 all over 9 minus a -1. I'm not skipping any steps on this because I just want to make sure y'all see every little bit of it.
Mm-hmm.
18i minus 6 all over 9 minus a -1 is 10.
Mm-hmm.
Which I have to write the top part in standard form. Now, everything in this, the -6, the 18, and the 10,
Mm-hmm.
can all be divided by 2.
Okay.
So my final answer will actually be 3 plus 9i all over 5. Now that is Miss Sparks's lazy way of writing it. In the back of the book, I think it's written -3/5 plus 9i over 5.
Oh yeah, she talked about how, like, it's written different. I think she said that we could write it like the way that you write it, but like eventually we'll have to write it like with the 2 separate fractions.
Yeah. You know, what I would say is that you need to be able to recognize it both ways. Because I don't really know how it's going to be on a SAT or ACT if it's actually on there.
Yeah.
Imaginary numbers. Do you remember if they were on there even?
I did not have any imaginary numbers.
Okay. Momo's just said on the SAT and ACT, she didn't have imaginary numbers for either one.
Well, thank goodness, because
But they could. I mean, they could be. I could
Yeah,
pick on one.
she's you know, she said that, you know, the random bank of questions, everybody gets something different.
Right.
So
Right.
all right. You'll just be blessed enough to have it, Brookie.
Yeah.
Okay. All right. So we'll move on to 31, which is of course different. It's not really a full conjugate. So yeah.
Yeah. I love that.
Yeah. The conjugate ones are a little harder, but the other thing that you need to know is being able to recognize what is in the denominator and what do I really have to multiply by in order to get there not to be a radical in the denominator.
Right.
Okay, so looking at number 31, the denominator is 12i. So one might think, oh, I've got to multiply it by, 12i. But in all reality, you only have to multiply it by I, because the 12 is just fine. It's the I that you're trying to get rid of, right?
Okay, yeah.
So, don't make it too hard on yourself, because you multiply everything by 12, you've got these really big numbers, and you're going to end up just factoring it out in the end and all that good stuff. So just make it as easy on yourself as you possibly can. And obviously, when it's a conjugate, there's really not any shortcuts to that in any way, shape, or form. But when there's only an I multiplied by a number in the denominator, like number 31, number 31 is like that, but on number 33, we go back to multiplying by the conjugate again. So, and I just looked at the answers, and they're really big, big numbers. So, yay, can hardly wait to get to that one.
Yeah.
I always love it when there's something like 106 in the denominator. Those are my favorite.
Mm-hmm.
All right. Garrett, are you still with us?
Yeah.
Okay. 4 plus 9i all over 12i. So this one, you just have to multiply the top and the bottom in order to rationalize it by I over I, that's just a form of 1. Whatever you do to the bottom, you have to do to the top, so you don't change the value of the fraction. And so now what I'm going to do is distribute the I to both things in the numerator, because that's a whole grouping up there, and I have to treat it as a grouping. So I times 4 is 4i plus 9i squared, all over 12i squared. So I've got 4i plus 9 times a negative 1, all over 12 times a negative 1. So this is going to be 4i minus 10, or minus 10, sweet Jesus, minus 9, all over negative 12. So I'm going to rewrite that. Negative 9 plus 4i all over negative 12, which really is, this is a time where I guess it's good to write it as separate fractions, because if we do, we can reduce this one.
Okay.
And we can reduce the second one separately, whereas if you weren't doing it like this, you couldn't do that. So if here 3 goes into both of those, so that's going to end up being a negative 3 actually. So the negative comes out.
Mm-hmm.
3 goes in, negative 3 goes into negative 9 3 times, and negative 3 goes into negative 12 4 times, plus 1/3 I. So that's a good example of where you really are going to want to separate them, because had I not done that, does that make sense to you guys?
Yeah, but like when you're separating the fractions and you have 4 over 12, why is the 12 like not negative in the second one?
Oh, because Miss Sparks forgot to write it.
Oh, okay. Okay, wait. So then, okay, that's new.
Huh? Mom was making fun of me because I was talking about myself in third person. Yeah. That means you're crazy, but y'all know that I am anyway. But so that's why.
Okay, I just wanted to
forgot to write it.
No, that's okay. I just got confused.
So fun times on that one.
Mm-hmm. Always.
Did you get everything written down, everybody?
I did, yes.
Did you get it, Garrett?
Yeah.
You have any questions?
No.
Okay. That was 31, right?
Yes.
So now 33. We're back to the conjugate on 33.
Okay.
And then we've got minus 1, minus 6i on the top, all over 5 plus 9i on the bottom.
Mm-hmm.
So the conjugate for this one is 5 minus 9i. Because all you're doing is changing the sign in the middle, because we want to do that. It's all based on the difference of two squares, so that middle term will cancel out. So the denominator is going to be really easy, but you actually have to FOIL the top. So we've got first, which is going to be -5. And then we've got outside, which is -1 times a -9i. So that's going to be a positive 9i. And then inside, which is -6i times 5. So that's going to be a -30i. And then last, so -6i times a -9i. My 30 is kind of ugly. Is 54i squared, all over 25 minus 81. And I'm just going to go ahead and convert my I squared to a -1. Is that okay with you all, or is that confusing?
That's good.
Yeah, that's good.
Okay. So now I'm going to combine like terms on the top. So I've got -5, and then a positive 9 combined with a -30 is going to be a minus 21i plus 54 times a -1. And then this on the bottom is going to be 25 plus 81, because a -81 times a -1 is plus 81. So that's going to give me 106 for my denominator. And now I'm going to go back and finish simplifying my numerator, which 54 times a -1 is a -54. So a -5 combined with a -54 is a -59. That's my real number. So to stay true to format. Whoops. Over 106, or -59 over 106 minus 21 over 106i. And 106 is not really divisible by anything but 2, and 59 nor 21 are divisible by 2.
Yeah.
So that's your final answer. And it is ugly.
Yeah. That's what's weird about like when I do it, then I think it's wrong.
When you get something like that,
Yeah.
I know. Isn't that right?
Yeah.
I know that's one of those things when you look it up in the back of the book and you see that you did it right and it's that ugly, you're like, I'm a genius.
Yeah, no kidding. I'm like, that cannot be right. That looks awful. But
I know.
I guess so. Right.
Yeah. Anytime you come up with a fraction and the denominator is 106 or something like that, and you've got some weird number on the top, you're like, whoa, you're right. You're always going to second guess that answer.
Yeah.
So it feels really good. That's why I'm like, oh, I at least on some of these, I at least want to make sure we're doing odd numbers so you can feel good about yourself when you get through something like that. Look at the back of the book and it's right.
Mm-hmm. For sure.
Okay. So 35, 37, and 39, those are all nice little gifts.
Okay.
You just need graph paper for those. But we're going to work on them. But I'm going to pull up my graph paper for this so that we can do that. And also I want to share with you guys, there's some really cool graph paper and it's free online. As far as like, you don't have to pay for the format of it. But it comes with 4 graphs to a sheet of paper. So for problems like these, it's kind of nice to have something like that. Just because it kind of keeps it in one place and then you don't actually have to do the drawing. So. Helps if you spell blank right. Okay, so for number 35, you're supposed to plot the complex number. And so I'm going to make this one 35. Oh. And then, so number 35 is -5 plus 3i. And the x is the real axis.
Yeah.
And the y is your imaginary. So you're going to go over 5, 1, 2, 3, 4, 5, and then up 3. And you're good.
That's so nice.
That's why I said you're going to think this is a gift.
I like that one.
Yeah, that's why I was like, oh, these are going to be fun. So that's all. That's really all you're doing. So for number 37, 4i. So that's technically there's nothing on the real. So that would be like the real is 0, and all you're going to do is go up 4. And then 39 is.
Hey, can you slow down a second?
I'm sorry. Yeah.
I'm trying to write it down.
Number 39 is this at 5. So 1, 2, 3, 4, 5. And then you're going to go down 5.
Yeah.
Do you have that, Garrett?
I'm on 37 actually.
Oh, okay.
Okay, now I'm on the next one.
Okay. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that's 41. And -2 means that you're not going to go up or down at all on the imaginary axis. It's just here. I'll give y'all a minute to get those. And then what, we have 2 left?
Yeah.
Praise the Lord.
Mm-hmm. That's what I'm talking about.
Okay, I got it all down.
Okay. So I'm going to go back over to my blank piece of paper. And then for the absolute value, to find those, the formula just says that the absolute value of a complex number is equal to the real number squared plus the imaginary number squared. Because basically you're working with the distance.
Okay.
So given that formula, we're going to look at number 43 and kind of plug in what is the absolute value of, I'm trying to get the, say, negative 3 plus 10i.
Mm-hmm.
So we're going to take negative 3 squared plus 10 negative 10 squared because of the I.
Why is it negative 10?
Because if I was actually taking hang on, let me think about.
Is it because like the I is like -1? So you just go ahead and
Yeah, but I'm actually, once you square it, you wouldn't have to. So let me hang on. So you're gonna have 9 plus 10, 100. So it's gonna be the square root 109. Hey, Mo, can you tell them? Because they're crazy. So it is the square root, because once you square that and take the absolute value out, it's not negative anymore. So it's just the square root of 109. I'm sorry about that.
you're good. I just
Yeah, clarify it.
yeah.
Is this
So
last
yeah,
one?
you're just, I'm sorry. And that's as
45
far as you have to go. You're done.
Okay.
What did you ask, Garrett? I'm sorry.
45 is the last one, right?
Is what?
45 is the last question, right?
Yes, sir. So we have -1 minus 6i. Now this one, Brooke,
Mm-hmm.
is negative there squared because of the minus here.
Yeah.
But it's not really going to make that much difference, because once you square it, that goes away,
Yeah.
because distance is always going to be positive.
And you
So-
just leave it as those square roots. Like you don't have to do the factor tree thing where you like break it down.
On the ones that you were assigned, the blessing is they don't factor down any more than that.
Oh, even better.
Yeah. So if they could have been, yes, you would have had to do it, but neither 43 nor 45 can factor anymore.
Okay. Well.
Yes. So that's a blessing.
Perfect.
Thank you so much, Ms. Sparks.
Hey, no problem.
Yeah. Thank
Glad,
you. That helped me so much.
glad to help. And now that's done.
Yeah.
All right. Any other questions about anything else that we've covered in the past few days? Because I know I kind of jacked up math lab last Thursday.
I think I was there.
I don't think so.
Okay.
I think I'm good.
All right. Well, y'all are always free to email me also. Okay.
Sure.
You can email Miss Wynn or me if you have any questions, okay?
All right. Thank you.
All right. Y'all have a blessed afternoon. Take care.
Thank God. That's how you should